Welcome back. This is the second lesson that I'm doing on electron structure of atoms, where we will look at the placement of electrons as well as some examples. So the basic information we get from the periodic table is the following. You'll get the symbol of the element, for example, let's choose calcium. And there are two numbers on the periodic table for calcium. The one is the mass number and the other one is the atomic number. Now this one, the atomic number, that one is the important one for electrons because that tells you how many electrons there are. There will be 20 electrons. So the atomic number is important. The second thing that is important is the period in which you will find the element. Calcium is in period 4. Now this information tells you that there are 4 energy levels. With electrons. Right. From grade 8 to grade 9, let's look at what we learned in grade 8. In grade 8, we wrote down, for example, calcium with the mass number as 40 and the atomic number is 20, and we would say there are 20 protons and 20 electrons and 20 neutrons. And we would draw a diagram to represent the electron. We would say 20 protons in the nucleus and 20 neutrons in the nucleus. And we learned that there are 4 energy levels, 1, 2, 3, 4, and we labeled them, and we said in the first energy level there can be 2 electrons, in the second energy level 8 electrons, and in the third energy level another 8 electrons, and 8 and 8 and 2 is 18. So to take it to 20, there must be 2 more electrons. And we said the electron structure is 2, 8, 8, 2. Now we're going to go into grade 9, where we draw the electron structure for calcium in an Aufbau diagram. The Aufbau comes from German for building up. So calcium is in period 4, so there are 4 energy levels in calcium atoms with electrons. So E is for energy 4, 3, 2, 1 energy levels. And in the first energy level you have only the 1s orbital. In the second energy level you have the 2s orbital. And hanging from the ceiling in the second energy level you have the 3, 2p orbitals. Then in the third energy level you have the 3s standing on the floor and the 3p orbitals hanging from the ceiling. And we go up to the 4s orbital in the fourth energy level. So that is what we are going to do. And we're going to represent the electrons with arrows or half an arrows. That would be representing one electron spinning in one direction and another electron spinning in the opposite direction. And we're going to do SP notation as well. Good. So there are 2 rules to place electrons in orbitals. The first is called Pauli's exclusion principle, where a maximum of 2 electrons with opposite spin will fill the lowest orbitals. S orbitals are always the lowest, so they will get the electrons first in an energy level. This represents one electron with a specific spin, so it is a half-filled orbital if it's got one electron. And this represents 2 electrons with opposite spin in the orbital, so that is a full orbital. Second, we get Hund's rule. Each p orbital in an energy level will get 1 electron before any of the p orbitals can be filled. What do I mean? If there are, for example, an element worth 5 valence electrons in the second energy level, the lowest orbital will get 2 electrons with opposite spin, according to Pauli. Then the p orbitals will each get 1 electron before they can get a second electron. Okay, so there we have 3 half-filled 2p orbitals. Our first example is lithium. So I'm going to go from basics. I write down the symbol for lithium. The atomic number is 3. That tells me that I've got 3 electrons to place. And the period is 2. So that means that I've got 2 energy levels to work with. So in the Aufbau diagram, I draw the 2 energy levels. In the first energy level, I make a circle to represent the 1s orbital. In the second energy level, on the floor of it, I make a circle and I write 2s. From the ceiling of the second energy level, I draw my 3 2p orbitals hanging from there. So I use Pauli's exclusion principle. A maximum of 2 electrons with opposite spin will fill the lowest orbital. So I've got 2 electrons there, and the next electron goes into the 2s. So this is the Aufbau diagram for lithium. The sp notation would say lithium, atomic number 3, colon, 1s orbital takes 2 electrons, 2s orbital took 1 electron. This is called my valence or energy level, and in it I've got 1 valence electron. The other electrons are called core electrons. So I've got 2 core electrons. Sorry, let me just do that. 1 valence electron. So this is my valence electron in the valence energy level, and these ones are the core electrons. Example 2 is nitrogen. So nitrogen has an atomic number of 7, meaning that it's got 7 electrons. It's in period 2, meaning it's got 2 energy levels. So when I draw my Aufbau diagram, it's got 2 energy levels. So on the first energy level, on its floor stands the 1s orbital. Second energy level, on the floor stands the 2s orbital. Hanging from the ceiling are the 3 2p orbitals. Using Pauli's exclusion principle, a maximum of 2 electrons with opposite spin will fill the 1s orbital. Then we move to the 2s orbital. Maximum of 2 electrons with opposite spin will be in the 2s orbital. I've used 4 of the 7 electrons. Hund's rule for the p orbitals, each one gets 1 electron, and I've used all 7 the electrons. There are, the valence energy level is energy level number 2, and there are 5 valence electrons and 2 core electrons. So the Sp notation for nitrogen, to represent the electrons in the 1s orbital, there are 2 electrons. In the 2s orbital you have 2 electrons, and in the 2p orbitals there are 3 electrons. These together make the 5 valence electrons, and that would represent the core electrons. Example 3, the last one for this slideshow, is argon. So argon has an atomic number of 18, so there will be 18 electrons, and it's in period 3. So period 3 means 3 energy levels. So I need more space here. First energy level, second energy level, third energy level. E for energy, 3, 2, 1. In the first energy level you have the 1s orbital, 2s, 2p, 3s, and 3p. So to place 18 electrons, 1, 2, 3, 4, using Pauli's principle, 5, 6, 7 to use Hund's rule, 8, 9, 10. So these are my core electrons. There are 10 core electrons. To carry on, 1, 2 for Pauli's exclusion principle in the 3s, Hund's rule, 4, 3, 4, 5, 6, 7, 8. 8 and 10 is 18, so I've got 8 valence electrons in the third energy level. Lastly, the Sp notation is argon, atomic number 18. 1s takes 2, 2s took 2, 2p took 6 electrons, 3s took 2 electrons, 3p took 6 electrons. And you can see that the third energy level is full of electrons, so that is why argon is stable. Or we could say it is inert. Right, if the energy level of the electrons, the valence energy level, is not full, the element is reactive. It will readily react with other elements. I'm going to stop the video here. I'm going to post it on YouTube and share the link with you on WhatsApp, and then we will carry on from there.